x minus 2. In other words, can you keep going? You have to factor completely. Now, where does that come from? If you have 12 and I say find the prime factorization, I mean, that's essentially what you're doing. You find the prime factors. You can go, well, that's 2 and 6. And if you just stop there, well, that's not the prime factors. 6 is not prime. You can keep factoring this. You can keep separating 6 into 2 and 3. So that's essentially what we've done. We've taken this first thing, we've broken it into those two things, and then you can break that up into those two things. So it's prime factorization is really what it is. The perfect cubes. 1 to the third is 1, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, 5 to the third, 125. Got those?
Yeah.
All right. I should probably go full screen on this. Let me do that. View, zoom, entire page. 6 to the third is 216. Those are the ones I have memorized. I don't have 7 to the third memorized. So if we're going to go above that, we're probably going to let you, well, we're probably going to let you use calculators anyway. This is 343. This is 512. These are the numbers that you want to look for today with how we're going to factor. That's 729, and I actually know 10 to the third is 3 zeros. 1,000 is a perfect cube. So those are your perfect cubes.
Everybody got it?
All right, here we go. New rules. The sum of 2 cubes. This, can I get this out of here? Yeah. Cut this. Cut that out of there. A to the third plus b to the third is that. I know that when it copied, it didn't, it just kind of covered it up. Same, opposite, plus. Talks about the signs. So if this says a to the third plus b to the third, this will be the same sign. Then it will be the opposite sign of this. And then it's always, well, no, I shouldn't draw that. I shouldn't draw that one because this is the same. This one will be opposite, and this one's always plus. Same, opposite, always plus. And it works with the difference of 2 cubes. So the same sign, then it's the opposite of the sign, and then that last one is always plus. That's how the difference in the sum of 2 cubes factors. That's the pattern. So there's a pattern there. Math is all about patterns. So that's your SOAP rule. Same, opposite, always positive. I say always plus, but positive, same thing. Factor each third degree polynomial. Let's not do that. Let's go off to the side here. And let's multiply x plus 2 times x squared plus 2x, whoops, opposite, same, opposite, minus 2x plus 4. Let's multiply this out. I want to do this first. So kind of off to the side, there's some white space. Let's write this. And here's how you multiply this out. You distribute the x. Distribute the x through. X to the third minus 2x squared plus 4x. Yep. Multiply the 2 through. You get plus 2x squared minus 4x and then plus 8. Now look what happens to the middle two. They're opposites of each other. This becomes x to the third, that's 0, and it becomes plus 8. Well, those are 2 perfect cubes. That's the sum of 2 cubes. And the pattern works. When you multiply it all out, you get the sum of 2 cubes. So now we're asking, what do you multiply out to get this? Well, this is x to the third plus 6 to the third. 216 is 6 to the third. So your first is x plus 6. Same sign. Then you have x squared, and the next one is the opposite sign. It's minus a times b. If this is the a, and that's the b, minus a times b would be 6x. And then it ends with b squared, which is 36. So there's the pattern. Now if we multiplied that all out, we would get x to the third plus 216. The 2 middle ones would cancel each other out. Factor each third degree polynomial where there's only one. This is x to the third minus 4 to the third. 64 is 4 to the third. 64 happens to be 8 squared, but we're working with thirds. Powers of 3 here, not powers of 2. So your a is x, and your b is 4. And then we follow the pattern. If you look at the pattern, it says a minus b, a squared plus ab plus b squared. It's always the same sign, then the opposite sign, and then always ends with plus every single time. So now we just follow the recipe. It's like you're cooking for Thanksgiving dinner here. We just follow the recipe. X minus 4, x squared plus 4x plus 4 squared, which is 16. You have the a and the b. You just follow the pattern. Once you know the pattern, this is all the same stuff. Just over and over and over again. 4 is not a perfect cube. It goes 1 and then it goes 8. 4 is in between there. 4 is not a perfect cube. Happens to be a perfect square, but that's not what we're looking at. We're not trying to find perfect squares here because we have an x to the third. But we can factor a 4 out. That's x to the third plus 8. Those are perfect cubes. X to the third is a perfect cube. 8's a perfect cube. So to get the sum of two cubes, we had to factor out. Now you got to bring the 4 with. This is x to the third plus 2 to the third. So your a is x and your b is 2. Then you follow the pattern. It says x plus a plus b. A plus b. It's the same sign. Same sign. Then the opposite sign. It happens to be a squared minus ab. And then plus b squared. The pattern. A plus b. A squared minus ab plus b squared. They will never be all the same signs, by the way. It's always the same sign, then the opposite sign, and always plus. What do we have next? Try that one. This one's interesting. See if we're getting the hang of this. This one's is a little tricky because now we have a number out in front. That changes things a little bit. That changes the game just a little bit. If you plan on going to the football game tomorrow, it's supposed to be chilly. It's supposed to be a little rainy, possibly. We're hoping it ends by game time, but you never know. If you're not going to the game and you're interested in watching, it will be on TV. It's on public television. So it's on that channel. Now this one, the A is both the 2 and the D this time. That's to the third right there. And then minus 5 to the third. So the A happens to be 2 things instead of 1 thing. It's not just the X. It happens to be a number and the variable is the entire A. So your A is 2D and your B, in this case, is 5 in the pattern because they use A's and B's in the pattern. The pattern says A minus B, same sign, A squared plus AB plus B squared. There's your pattern right there. That is the difference of 2 cubes. Your A is 2 things. We're going to have to deal with that. Well, first we're going to have to square this. We're going to have to square the 2D. Well, that becomes, actually we have to do this first. 2D minus 5. Let's take care of that. There's A minus B. A squared, that's 4D squared. You got to square both of them. You can't just square the D and call it good. You can't have 2D squared. You can't do that. But you can, but it's totally wrong. And then plus, we multiply these 2 together, which makes that 10D. And then we square the B, and in this case, that is 25. So there it is factored right there. Little different when you have that number out in front. You got to take care of a little bit more. Any questions on that? All right, so now we're getting away from the sum of the difference of 2 cubes. Now we're going to go to an x to the 4th. Well, if this was x squared plus 9x minus 36, I'd factor it like this. I'd have x, and let's go with plus 12 and minus 3. That's how we'd factor it, and we'd be done. Well, we don't have an x squared and an x. We have an x to the 4th and an x squared. So now we split this up into x squared times x squared. That's first. X squared times x squared, that would give us x to the 4th. And I still need factors of 36 that add up to 9. And that's still plus 12 and x squared minus 3. Right? Because we get 9 out of that. We get a positive 9. Just happens to be x squareds. Now, this is the one we have to take a look at. Is that the difference of 2 squares now? If it's a difference, x is being squared, is 3 a perfect square? It is not. Now, if that said x squared minus 9, or minus 16, or minus 25, we'd have to keep going. But in this case, we're done. You stop there. It's completely factored. I'm sure they're going to give us one of those. They have to, where we have to keep going. And I think this is it right here. X squared. X squared this time because we have an x to the 4th. X squared splits into x and x. X times x is x squared. Factors of 12 that add up to 7 are minus 4 and minus 3. But aha, we have to consider both of these. We have to consider that one. We have to consider this one. And the one on the left is the difference of 2 squares. This factors into x minus 2, x plus 2. But this is not the difference of 2 squares. We do not split that one up. It has to be a 4 or a 9 or a 1 or a 16. It has to be one of those perfect squares off to the left here on the board. You have to keep going. I will give you points for the first line, but if you don't have the second line, I got to take a little bit off because you didn't finish the problem. And I don't want to do that. I do not want to do that. Try that one for me, please. This one is, you really have to keep going on this one. That was a minus 10. Yeah, plus. Yeah, that would have been a better one. All right, so this one, x squared minus 9 and x squared plus 1. That's what it factors into first. Now, this one over here to the right does not split into x plus 1, x minus 1. It does not because it's a plus in the middle. We don't have the sum of 2 squares. We only have the difference of 2 squares. So this is x minus 3, x plus 3, and there's nothing you can do with that one right there as far as factoring it. That's it. Factors of 4 that add to 5, x squared plus 4, x squared plus 1. Neither one can be factored. Now remember, it's the difference of 2 squares that can be factored, not the sum of 2 squares. You can't do that. There's no pattern that gives you the sum. There's a pattern that gives you the minus. That one is completely factored. There's nothing else you can do. All right. Minus 20. Eight and 8, 16. What else do we have? 16 and 4. Thank you. 16 and 4. Both of those are the difference of 2 squares. Both. So they're both perfect squares, and it's both minus. X minus 4, x plus 4, x minus 2, x plus 2. There's no order to that, by the way. Hopefully you know that. That you don't have to have the exact same signs in the exact same order. Just one has to be a plus, and then one has to be a minus. So we have sum and difference of two cubes. We have factoring in x to the fourth. This third one is factored by grouping. I think we've already talked about this one. We group the first two, we group the last two, and when this is a minus, we have to change this to a minus. If the one in the middle is a minus, we have to change the last one. They have to match. This one has to match that one right there. Well, now we can take an x squared out of the first, and we get x minus 3. So we factor out what we can out of the first group. Then we factor what we can out of the second group. Minus 4 times x minus 3 now, because there was a minus in the middle. When there's a minus in the middle, we have to change that last sign. Here's what happens on the factor by grouping. These two come back together, and they're going to make x squared minus 4. Then these two come together, and they make an x minus 3. They do not make an x minus 3 squared. That's not the way the pattern works. It seems like it should, because we're always told when you multiply two things together that are the same, you get squared. But this is more about pattern. This is a pattern. We're not multiplying these two together. We're bringing them back together in the pattern, and that's the pattern right there. It is not squared, and I have lots of students that have tried that in the past. Well, you got to be careful because you're not done. X minus 2, x plus 2, x minus 3. So you have to always be looking for patterns of usually it's difference 2 squares, I'll tell you right away. Now if that was x squared plus 4, we would have been done. There's no sum of 2 squares, no matter how hard you try. I think this is the last one right here. Last one. There are 4 terms. Notice the difference between this and the ones we had before. There's 3 terms, 3 terms, 3 terms, 3 terms, and finally we get to 2 terms. So it's 4 terms that is a factor by grouping. All right, so 4 terms. Factor by grouping. That one's a plus, so we don't have to change the sign. Only when it's a minus in the middle, then we have to change the signs. We can take an 8x to the third out of this. Wow. And we get 2x minus 1. Now, it does not go away when we factor stuff out. It doesn't go to 0. It's division. 8 divided by 8 is 1, not 0. When we factor out, it's division. That becomes a 1, not a 0. And then plus really 1 times 2x minus 1. We can't, there's nothing you can take out of 2x minus 1 except for 1 is the one you can always take out. These two come back together. 8x to the third plus 1. These two come back together as a pattern. It's not multiplication. It's not squared. Well, this one's really tricky because that is the sum of 2 cubes right here, where your a is 2x and your b is 1. This is not completely factored. It's 2x plus 1. There's the pattern. Same sign. Then it's 4x squared opposite sign, minus 2x. End it with b squared, and you got to bring that 2x minus 1. That's probably the toughest one we've done. You weren't done with that one. We have a pattern that we've talked about, the sum of 2 cubes. Got to keep going. Always got to keep going. You have to convince yourself that you're done with these problems. Am I done factoring this? That always has to be on the top of your mind. Am I done with this when you take the test or quiz or whatever? Any questions? There we go. There's your patterns for the day.